Thanks for the warm welcome, everybody. Nothing like a baptism of fire. First night at LNUG, Aaron speaking. So I hope I hit the mark with the topic. So I'd like to talk about Fullstack BDD. BDD is something that's close to my heart. I've spent the best part of the last 3 years introducing it at the company I work at and feeling the pain. So this is somewhat a tale of woe, but also some successes. But could I get a show of hands? How many people are familiar with behavior-driven development or test-driven development? Okay, now keep your hand up if you do either of these two things. Okay, that's good, brilliant. So this is not yet another talk about how to use feature files to drive automated testing of your website. This is talking about some of the higher level principles, some of the side effects of doing BDD, both good and bad. I am, for my sins, CTO at a company called Invika. You won't have heard of them. We don't do Node particularly publicly right now. That will change, hopefully. I'm trying really hard. I'm somewhat of a polyglot programmer. I've been doing it for 15 years, various languages. Some of them I don't wish to remember or mention. But the big thing about me is I am driven by the question why. So that's what drives my interest in BDD. Why am I writing the code? Why is it important? Is it good enough? Could it be better? Is it enough right now? And I'm also not saying that if you're not doing BDD, TDD, DDD, you name it, you're doing it wrong. It's about choosing the right things for the right time. If your software is an experiment, who cares? Hack away, solve a problem. If it's guiding spaceships to another planet, you probably want to test it. Quality matters. But it depends where you're applying your software. But I'm going to make a bold assumption that everyone sat here tonight is a technologist. You're interested in solving hard problems with tech, which means you probably, possibly, kind of fixate on the tooling part of things. Your first instinct is to find a tech solution to a problem. By the end of tonight, hopefully we're going to flip those around. So, because it's somewhat dangerous to fixate on the tooling, because you start to fall into structured, formal practices that maybe stifle what you're trying to achieve, or they lead you down a path that leads to untold cost and hard work and unpicking that somebody somewhere will then go, why have you done that for the last 6 months? There's no value. Throw it all away. BDD is hokum. Stop it. It's no value. I think, from experience, it's not hokum. It does have value, but we have to extract that. The tool selection available to you as JavaScript and Node engineers, there's a myriad. I named 3, but this slide could go on forever, and I see new ones pop up all the time. All of them, to some extent, offer the tools you need to do TDD and BDD. They're just tools. Pick the one you're comfortable with. Pick the one that meets your needs. You can achieve the higher level principles with whichever you choose. I'm going to cover Cucumber because I think it better maps to the higher principles. It's easier to make that leap. But you could do this with any of the tools I mentioned on this slide, plus the others that you could find. To me, BDD is about translation. Translating the conversation between the person requesting the feature, the business stakeholder, or the end user, whatever context that may be, and the engineer that's writing the code. And that doesn't mean it's about functional testing. If you go read the Cucumber docs, it's all about driving your application through a browser. It looks like functional testing. It's driven by Selenium or Phantom.js. It's everything about functional testing. But that's not BDD. That's not BDD at the heart. But if you go and read the repo for Cucumber, you'd be forgiven for making that mistake. The feature files, as an example, talk about visiting a website, interacting with a web page, reading the content of that page and validating that it's what you expect. And then when you look at the glue code that glues that together, again, you can see that we're talking about that doesn't show up very well, does it? About a browser that visits a URL. Okay, so it's quite easy to see why everyone that ever starts to look at Cucumber, whether it's the Ruby version, the PHP version, the JavaScript version, thinks it's about functional testing. But the language gherkin that you write your feature files in, it's plain English. It's easily used to translate the conversation with your stakeholder, with your developers. And that's what it is. It's a collaborative forum to start that conversation, to form a ubiquitous language, something that makes sense to both parties, something to start describing the business domain and building a deep understanding of what that domain model is. Because the business domain is what sets any business apart or any application apart from any other. That's their point of unique. That's their unique characteristic. Every website has a login form. Every website has a sign-up form. But what you do after that is the unique part. So writing functional tests for a login form has pretty much no value from a development perspective. It's a nice regression test to make sure you haven't broken things, but it's not about driving value. You could start to write features using an example such as this, where we don't have a great deal of implementation detail. It's not about driving a website. We're starting to talk about some value. We're starting to talk about a benefit to an end user. In this case, it is still an engineer. We're still talking a technical benefactor of that value that we're delivering. But we're talking at high level. And one aspect that you can start to extract from this type of feature writing your value statements in this way, is you start to build examples of how your domain works. And you do it in domain terminology. And those domain terms, so in this instance we're talking about a circuit breaker and a request, they're very likely to become objects in your code that you write. So this statement translates into the objects that you've written. Now, if we build that, if we start to link this in our glue code between our feature file and our testing framework, the mechanics of Cucumber is not something I'm necessarily going to cover today. Happy to answer questions after I've finished speaking about how Cucumber glues together. But the concept here is that we're starting to do domain-driven design by accident. The feature file started to describe the domain, and we're getting a side effect of, we've started to model the domain as well. We're modeling the domain by the examples in the feature files. So if we can look to build this into our development workflow, and essentially TDD and BDD all things, which we've done, and we've felt the pain of adopting it. So believe me, it's not simple, and it's not something to be taken lightly. But our development workflow has been condensed into 20-minute cycles of red-green refactor. We write the test, we have a red broken test, we write just enough code to turn it green, and then we step back and we look at that code and we do the hygiene steps. We refactor, we clean that code. It's not something we delay for later, we do it every 20 minutes. That gives us the opportunity during the refactoring. So to clarify, refactoring is changing the internal behavior without changing the external surface of the application. So any of our interacting code, any of our modules that are dependent on the code we're writing, will continue to interact the same way, but internally we can clean it up. It gives us the opportunity to begin designing the code and turning it into something that's maintainable and understandable. That doesn't mean simply regurgitating the Gang of Four book into your code. There's value there, believe me, there's value there, but don't go reading the Gang of Four and thinking, I'm going to shove them all into my code. Yes, they're OO patterns, but I believe they're transferable regardless of whether you're doing functional programming, OO, Node, JavaScript, any other language. Likewise, the SOLID principles. these kind of start to emerge when you have that constant refactoring step. The ability to start refactoring and spotting some of the principles around Solid are really valuable. Now, some of these can be fairly weighty, not always relevant to Node and JavaScript engineering. But one of the key things to mention, and this comes from very well felt experience, is beware of the complexity that starts to creep in. We spent a long time investing in our engineers and educating them on kind of more high level software engineering principles. What we found was they took it all on board, they learnt all of them, and then they put them into the code they were writing. The code became hugely complex with very little value. So one of the best books I've read to help counter that is a book by Corey Haynes, which is essentially condensing all of those concepts down into 4 simple rules. And again, it fits really well with that BDD 20-minute workflow of red, green, refactor. So first of all, you're in a position that all your tests pass. You've written a small amount of test code, a small amount of application code. You're in a green passing state. Then you look at your code and ask, does it express the intent? If I walked away from this code, the most elegant code that I've spent the last 3 hours byte shifting, so I've turned it from very expressive, verbose code into 140 characters. I've written my application in a tweet. However, in 3 months' time, I've got no idea what it was doing. Expressiveness and expressiveness of intent is key. And that's where patterns can help, because they clearly describe an intent. No duplication. Again, I see lots of people take that point and say it's about code duplication. What's more key is about business knowledge and business domain duplication. So you might have code that looks almost identical, but if it's not modeling the same concept, that's fine. If you've modeled the same concept in different places, then you're probably going to run into a problem later that we'll address shortly. And it should be small, right? Just enough tests, just enough code, build tiny modules. So says Substack. Yeah? That's one of Node's key philosophies, and Unix too. If you write less code, it's much easier to write clean code. If you write less code, it's much easier to write code with a clear intent. And from my perspective, all code has a user interface. It may be an NPM module. Someone has to consume that NPM module and understand what it does. So only expose the API that makes sense, and write an API that makes sense. The stuff that's plumbing, the stuff that's for you, how you got your stuff done, hide it, encapsulate it. And there are patterns to help you do that. Identify duplication and complexity, and use the tools available to you from some of those core solid principles, design patterns that will help you do that. But BDD is helping us drive this. I see this as kind of a side effect, but I've seen some common smelly parts to adopting BDD. And the first one is everything's hard to test, especially if you approach this as, I've got a project, I've got some legacy, I've got some code that I've invested loads of time in building, but some guy that thought he knew what he was talking about stood up at a user group and said I should be doing TDD and BDD, so I'm going to do it. So the first thing you'll say is the code's hard to test. Symptom here is potentially the code's tightly coupled. You've got some bound dependencies inside your code, or your code has awareness outside of its own remit. You've got inappropriate intimacy between objects or modules. Again, these are things that are symptoms, and there are solutions out there once you start to see the symptom. Your tests become expensive to maintain. Sorry for the typo. So lots of tests need updating when you change a small piece of code. Again, this is a sign of inappropriate intimacy between the code, but also close coupling and too many dependencies. So if you If you're using code test doubles and you've got to use lots of test doubles and you spend more time setting up your test doubles to exercise your code, again, it's time to start looking at your structures, reevaluating how you're composing your objects. More clear examples of BDD going bad. Again, you'll find loads of online examples that look like this. It's functional testing. It's driving Selenium or your chosen browser using Gherkin. But what's happened here is an engineer's thought, there's steps that are predefined. I can use those steps. I don't have to write glue code. And I'm getting loads of reuse here. That's a good thing. From university, everyone's told reuse is a good thing. What we've done here is we've pushed the implementation detail all the way up to the top of the stack, and now we've got brittle code scenarios, because the minute you change your UI, or the minute your UI isn't a web page, every feature file has to change. Every time you've referenced a UI element by its CSS value, or its name attribute, etc., it'll break. And web pages change, right? Changing your test suite at the same time is expensive. Tests fail for unrelated components. Again, this is definitely something that you'll start to see if you're beginning to test kind of legacy code. If you haven't started off with these concepts, that's normally a sign of code that doesn't conform to the law of Demeter. So you're reaching too deep into other objects. Really simple rule here, only one dot per statement. If you've got 2 dots per statement, you're probably stepping outside of the bounds of where that test should go, or where that object should be executing code. Probably means you've got more objects in your domain than you have modeled, and you should look at those. Try and find a domain element that you haven't yet described. Put it into your scenarios and start modeling. Should you adopt BDD? Been there, done that. It was expensive, but we've got a lot of value, and we've got value on behalf of our clients, because what we've gained is sustainable agility, the ability to adopt change into our applications without it really having an impact. We can change the way business logic works, we can change the way the UI works, and all of the benefits that we get from BDD are still there, and they're not actually getting in the way. It gives us the opportunity to constantly pay down technical debt. We're not in a situation where in 6 months' time, when we're asked to change a key part of the application, sorry, we might have to rewrite that. That's a piece of vocabulary that I hope with the successful adoption, my teams have kind of stopped using, and they see a clear path of progression. But how do we apply this to different levels? And it can be applied at different levels without too much overhead. So we can start to use these feature scenarios when they're abstract enough, they're not talking about implementation detail, to start driving the development of the domain model in isolation of any implementation of an application, such as an API, or even the UI. What this gives us the ability to do is drive any number of UIs, be that a mobile phone, a single-page web app, a multi-page web app, the API itself, and the domain, all using those common terms. Now, there might be some scenarios where there's some uniqueness to a given UI, but we can do that, and it's all done through, in Cucumber's case, using a dynamic world. The world is the context through which we glue our application to our scenarios. Using a dynamic world, so in this case I'm using an environment variable to load in a world object. And I can define a world object specific to the context I want to exercise. So in this case, the UI, it's a one-page Angular app, so I'm using protractor. And what I'm returning is an object that has the glue methods into that domain behavior. So in this case, we're scanning a product and we're checking the total. We can do exactly the same on the API, where this time it's an Express app providing a RESTful API using Supertest. So we're doing the same thing. We've made the same methods available on this world, but the implementation is different. So we're gluing things together in a different way. And finally, the domain, where we're just instantiating the objects directly and we're exercising them directly. We've got no Express app, no browser implementation. And then finally, the steps that we were testing against, they match, and the world is injected into here, so we can just call those methods against the context that we're operating on. I'm very happy to go through the mechanics of this after we've covered the principles. So, speeding along a little bit, the worst effects of TDD, definitely slow progress. Definitely affects velocity straight away. It's more tools to learn, it's new habits to form, it's muscle memory that you need to develop. Best effects, you're working from the outside in with test first. Primary symptom of that, you write less code. You write significantly less code. Less boilerplate, less code, easier to maintain, cheaper to write, cheaper to maintain. You clarify your understanding, you build the right code, and you've got documentation for your team, for bringing new people into the team, or for understanding that code 3 months later when you've had your mind on other things, other problems, when you come back to maintain it. From a BDD perspective, you've got all of those pains of TDD. You also need to get business buy-in. It's really hard to do BDD if just the tech team are driving it. If you haven't got a stakeholder that's prepared to collaborate, doesn't mean they have to write Gherkin. You don't have to sit them down and say, this is how you write the syntax. You do at least have to have them in a room and have a conversation. Driving out those examples through which you're going to exercise the domain is really key. Helping them speak the same language so that when you start to talk about your app, maybe you've got a defect, it's not quite right. If what you talk to them about, the particular object, the particular element of your application, maps to their domain, their understanding of the business, that conversation is so much easier. It can be a huge overhead if not done well, and that's something that grows exponentially. If you build a regression suite in Cucumber to exercise your application, and you connect it to your UI, and that UI changes, that the pain and the cost is immeasurable. But the best effects, and the thing that I've seen the most benefit from, is the focus on value. So every feature becomes focused on delivering something to the end user. Whether that's your NPM module, you're focusing on what problem am I trying to solve, or whether that's a feature for your business, you're focusing the stakeholders and the development team on that value proposition. And building that collaborative, shared vocabulary, the ubiquitous language, is absolutely key. And sustainable agility, or the ability to encompass change without effect. So, my premise for the talk at a high level is that as technologists we often start with this focus. We prioritize tools over practices, over principles. And in the scope of an online tutorial or a brief Stack Overflow question, often the solutions are focused on prioritizing tools. When what we should do is prioritize the principles and the practices, because the principles get you to the best end solution. They get you to the point where you can move beyond simply following step by step and producing the same thing over and over again, and understanding where you can get the best out of the tools and get the best value for your project. That's my brief intro to LNUG. Be kind. Any questions?
Just a link to agile practices.
Okay.
It's a state of agility that you mentioned. Doesn't that require cultural change that goes beyond the tooling?
It does, yeah. And I think that's kind of that high level concept that BDD brings. It kind of drives home the need for engagement at all levels, and rather than just being moving it beyond just being functional testing and being a conversation piece. Any other questions at all? Happy to talk about the mechanics or anything else after the other speakers. Yeah, cool. Thank you very much.